Hi, everybody, and welcome to this week's CosmoQuest Science Hour. I'm Emily Lakdawalla with the Planetary Society, and with me is Fraser Cain of Universe Today. And we
Hey,
are
Emily.
going. Hi, Fraser. And we are ready to talk about it. We're laughing because it turned out to be an incredibly fortuitously planned event, this hangout. There is some big news. Well, there's some big non-news out there in the media about something that Curiosity may or may not have found. And we're here to try to discuss what those things might be and what they might not be, and try to calm everybody down because you're not going to get an actual answer until December. So, um, anyway, Fraser, do you want to add anything to that before?
Well, no, and I think that's it. I mean, like, I know your natural instinct is to not want to speculate at all, to keep everything fully in the constraints of science, and to do a good job as a planetary scientist. And I know that the pressure will be on to push you to speculation. So we'll try to split the difference, which is, I think we'll try to learn about the instruments, learn about the rover, learn about the science involved, what things people are looking for, and then keep that speculation within that structure. So,
And
because
and
I'm
that's why I think you and I are a good pair, Fraser, because I'm always trying to be a wet blanket, and you're trying to be like, yeah, well,
oh,
but
come on, come on. Where's
all
your
right.
imagination? Where's your soul? Yeah, no, absolutely. So we will definitely be playing in that sandbox, I think. So,
So let's. Oops, my home phone is ringing. Let's begin by talking about what they've actually talked about. So just to give a recap, Curiosity spent about 40 sols at a place called Rocknest, which was a very small sand dune, kind of on its way to some rocks that they wanted to investigate. And they picked this particular dune because it had really, really fine soil that was absolutely perfect for their very first activities with their sample handling mechanisms. And so they took 5 different scoops of soil, they sampled it, and then they sieved tiny portions of very fine dust into their 2 analytical laboratory instruments. And these 2 laboratory instruments are the reason that Curiosity is so enormous. They're huge. They really are like having an entire scientific laboratory packed up inside a rover and sent to Mars. One of them is called ChemIn. That's an X-ray diffraction, X-ray fractionation instrument, and we heard about the first results from that one a couple weeks ago. The other one is called SAM, which stands for Sample Analysis at Mars. And SAM is an incredibly complex pile of instrumentation. It's 3 big instruments called a tunable laser spectrometer, a gas chromatograph mass spectrometer, and what's the third one? The quadrupole mass spectrometer. And all of these things are linked to this carousel of quartz cups that are on that can be heated to very, very high temperatures, because what SAM does is it evaluates the chemical and isotopic composition of gases. And so it can take in atmospheric samples and measure chemicals and isotopes, and chemical composition, or it could take a solid sample and heat it up so much that a lot of its mass is driven off as gases, and then measure what those gases are that are coming off the heated sample. And so it spent the 40 sols doing that. It got 2 samples into SAM and is actually still hanging on to a little bit of the last sample inside the sample handling mechanism. The project scientist for the mission calls that chewing their cud, because they're hanging on to this thing while they're walking along, while they're driving along to their next spot. And they actually have finally left Rocknest and are now standing at the edge of some really beautiful bedrock at a place called Glenelg, that they're going to be ready to start their first drilling at. So,
I don't know if you saw. I posted a picture of Sam. I don't know if you saw that. So
that's
this
the
is
right. So this
right.
is the inlet port for SAM. That's where the samples go into. And then SAM itself is this. It's a golden box that fills up half of the front right quarter of the rover. And I've actually got a picture of that I can share.
Oh, I forgot to do a little bit of the regular housekeeping, which is
Oh,
that this is interactive. So let me just quickly give that spiel, which is so we'll be talking about a bunch of stuff, and we will be speculating, but it's only half the fun. The other half is that we love to answer questions from the people who are watching. So if you have any questions or comments or feedback for what we're talking about today, you can post those questions. If you're watching this on the event page, you can post your question there. If you're watching this over on YouTube, you can post your question there. You can also use Twitter with the hashtag #Planetary Live, since this is the Planetary Society. We'll be using that hashtag. And you can also post it on Google Plus in either Emily's feed or my feed. And we should be able to get all of those comments coming in one place. So feel free to propose your out-of-the-box ideas for what crazy things have been discovered on Mars, and we'll address them one after the other.
All right, so I've got a picture of what this instrument looks like. It's about the size of a biggish microwave oven. Here's that carousel I was talking about. And then packed inside it, this is the gas chromatograph mass spectrometer. This is a tunable laser spectrometer. The quadrupole mass spectrometer is down here somewhere, and it's also packed with plumbing that can take all of the gases that are evolved from the little samples they put inside the carousels and shoot them to anywhere in the instrument. This thing is a mess of valves. It looks kind of like the plumbing system for a city. It's really complicated. And I actually had a lengthy conversation with the deputy principal investigator for this instrument 2 weeks ago on my last CosmoQuest Science Hour. So y'all ought to check that out to learn more about just how complex this instrument is and what it's designed to do. Okay, but the reason for all of the rampant speculation that's going on this week is an NPR story that is by Joe Palca, who is just a great reporter, and he was inside John Grotzinger's office. Now, John Grotzinger is the project scientist. He's the guy who's sort of the scientist manager for the mission. He's in charge of all of the principal investigators and all of their investigators. It's kind of like herding cats over there. It's really complicated, but he's a really good guy for handling it. But he seems to have made a little bit of a slip up this week in how he talked on air, on recording to Joe Palca. What he said was, there are exciting results coming in from an instrument in the rover called SAM, and quote, "We're getting data from SAM as we sit here and speak, and the data looks really interesting." He goes on to say that the science team is busily chewing away on it as it comes down. Then he says that this data is going to be one for the history books. It's looking really good. And so, yeah, so he's, let's see, yeah, I think that's basically. Well, where did he say something about earth shaking? I'm looking for.
Right. So he said, he said, a recent soil sample test in the SAM instrument shows something earth shaking.
Yes. Yeah. So we have earth shaking, and we have one for the history books, which is what has really set people off. Yeah. So I don't know where you want to begin with that, Fraser.
Well, I was actually talking to Phil last night, Phil Plate, who has been reporting on this as well, and we were going back and forth. And anyone who has any experience with NASA, in interviewing folks at NASA, knows how tightly they control a lot of this information coming out. That as a science as a science organization first, there's a very special way that you have to release these findings. You have to, find your data. You have to get it confirmed. You have to get peer review. There's various stages and ways that you do it. And to have someone speak off the cuff like that is very unusual. In my experience, anyway. I haven't had a chance to interview anybody at NASA without 3 people from the press office in the room at the same time.
Really?
Yeah, I've had those situations where people in the press office have wanted to sit in the interview and sort of oversee. So anyway, the way these, especially if it's something earth-shaking, very large findings. They tend to release this stuff in a very careful and controlled way. The discovery of an Earth-sized planet, the discovery, and then of course there's the sort of bad example of the discovery of arsenic-based life, or the non-discovery of arsenic-based life a couple of years ago. So it seemed very bizarre to me that this got released in this way, and now we're all madly speculating.
And Palca goes on to acknowledge that, because he says, he uses the example of the biosignatures, the supposed biosignatures found in the Martian meteorite, the Ellen Hills 84001, and the fact that you have to be very careful, even though you think something might be true, that you have to go back and check it multiple times, and often it finds out it takes peer review to falsify something. But there was actually a second example that Grotzinger cited from the same mission, from Curiosity. The first analysis that SAM ever did, just days after they set down on Mars, was a sample of the atmosphere. They took in a sample of the Mars atmosphere and they analyzed it. And lo and behold, that very, very first analysis showed methane, which is what everybody was hoping that Sam would find, because there's the story of possibly seeing methane on Mars through telescopes, and methane that was highly variable. And the only way that some people said you could have methane be so variable on Mars is if there was life that was creating this methane. And so that would have been a really, really important finding. But they were very careful. There were actually rumors that something exciting was happening on Sam, but they didn't say anything beyond something very exciting is happening on Sam. And then they did a second analysis, and what they figured out was that the methane had come from a small amount of Florida atmosphere that was actually still in the instrument. They had to evacuate that. Yeah, they had to pump it down to a much lower vacuum level. And Pam Conrad, the deputy principal investigator for the instrument, talks about that in our she talked about that in our hangout last week, and about how the second measurement showed no evidence for methane. And so I don't think that that's exactly the same thing as what's happening here. The fact of the matter is that SAM is a kind of instrument that has never, ever been sent to another body in the solar system before. And so any kinds of results that are going to come out of this instrument are going to be earth-shaking as far as geologists are concerned, because they're going to confirm or deny lots of different people's theories about how dust on Mars works, about how the composition of things works. So even if there is nothing sensational in this finding, and I'm not saying that there isn't, but even if there is nothing sensational, scientists are going to be absolutely gaga about what finally comes out of this instrument. However, the scientists are not going to get the kind of information that they're looking for until the beginning of December. And the reason they're not going to get it until the beginning of December is because that's when the next big scientific meeting is. It's the American Geophysical Union meeting that happens in San Francisco. Happens in the first week of December. I'll be going up to the first day to find out what the MSL team is going to tell us. And that's the way that these kinds of findings typically come out, is at scientific conferences where the scientists are actually presenting it to other people in the community who can then discuss the findings.
There is no way it's going to last until then. The pressure is going to be on for them to at least give people some kind of context before that meeting, or people are just going to be, the frustration is going to rise, and then the backlash will happen. So if I was NASA, I would get out ahead of this and just get, okay, fine, we found whatever, methane or organic chemicals or evidence of dust, and get on that, you know.
And that's actually what they wound up doing for the first SAM press briefing. So usually they had been in a habit of doing press briefings every Tuesday, but then one week they did a Tuesday one, and then they said, okay, we're going to have a Friday one. And that was the time that they did the SAM results. And you know what? The results were extremely underwhelming to a lot of people. They're like, why did you hold a press briefing for that?
Yeah.
And the answer was, it was because you guys were demanding that we hold a press briefing,
right?
Not because we had anything particularly interesting to report. So you're right. Fraser, I'm actually going to agree with you. That's probably what's going to happen. And my prediction is that they're not going to have anything terribly exciting to say, because there's nothing they'll be terribly confident saying.
So I think it would be really helpful to kind of give this whole conversation, put it in some context. I think this is a teachable moment where we can explain what the SAM does, what the instruments do. I mean, as you said, almost anything that's going to come out of this instrument is amazing, because nothing like this has ever been sent to another world. So what is the purpose of the SAM instrument?
Well, the purpose of the SAM instrument is to determine to a high precision the chemical and mineralogical composition of the atmosphere and soil and rock samples that they get inside it. There have been GCMS instruments, gas chromatograph mass spectrometers, that have studied atmospheres on other planets before. There are similar instruments in orbit around planets. There's one on Cassini that's scooping up the tiny bits of material and ions and things that are in orbit around Saturn. And what they do is a mass spectrometer, basically it takes gases that come into it and separate them out by atomic mass. And a very low resolution GCMS will only be able to go up to a very small atomic mass number. So you can look at gases, things like carbon dioxide and water and stuff like that. It takes more and more energy and a more and more complex instrument to be able to go higher in the mass spectrum. And SAM is a very complicated GCMS, so it will be able to detect and measure such interesting compounds as, say, amino acids, which I think is one of the things that I have heard of as that I think is a possible contender for one of the exciting things that they could have found in in this Martian soil. But Fraser, I think you're better than I am at explaining why finding amino acids might not be all that surprising.
Well, sure. I
On the
mean, there's
surface of
amino
Mars.
acids everywhere in space, right? I mean, astronomers look out into gas clouds in, star-forming regions, things like that, and they actually are seeing amino acids. They found alcohol, so they're finding a lot of these building blocks of life. It's theorized, what Titan. There's possibility of there's hydrocarbons. So there's a lot of these it's that step from amino acids to the actual building blocks of life, which is a pretty big step. But yeah, I know. I mean, there's a lot of amino acids discovered out in space. So
It's the fact that Sam can detect organic compounds and actually tell you kind of what they are, it's a really big deal. Nothing like this has ever been sent to Mars before. And they weren't actually confident that they were going to find any organics when they landed. They were very careful to define their mission success parameters so that it wouldn't depend on them actually finding organic materials. They were very careful to pick a landing site that would maximize the possibility that they could find them. But the notion that they might find them in a sand dune actually sounds kind of far-fetched to me, because this is material that gets blown around in the atmosphere, in an atmosphere that is very oxidizing and that is very electrostatically charged. And so you wind up having all kinds of reactions that bust these relatively delicate compounds down into much simpler compounds like carbon dioxide.
right. So it's not a situation where this stuff is protected in some stable form. It's instead being blown around and washed and scrubbed and radiated nonstop.
But on the other hand, and I think I'm on a third hand by now, the sand dune could be kind of old, and so maybe there's some way that there is some material inside it that could be organic. I mean, we have absolutely no information, and so I'm rather uncomfortable, as you know, speculating on absolutely no information. But
I'm happy to push you out of your comfort zone into speculation land.
Organics are one thing that Sam was sent to Mars to hopefully find.
But current organics, but also kind of evidence of past organics, right?
That's right. And so there's a big difference between detecting organics today and finding evidence for them existing in the past. Because one thing that we can say about the surface of Mars near the equator today is it is not a happy place for life. There is a very, like I said, an oxidizing situation, which tends to bust up these delicate organic molecules. You have ultraviolet radiation coming in. In general, life would have to be extremely tenacious in order to survive there. And now Earth life has shown us that it is extremely tenacious. So there are things that would not have to get very far below the Martian surface that might actually be able to survive over geologic time. But it's certainly not a friendly place for life to originate. On the other hand, Curiosity is there to look for environments in the past that would have been much friendlier, when the atmosphere may have been thicker, when there was certainly a lot more liquid water around, and when that water was of a more neutral pH so that it didn't tend to attack molecules that formed inside it. And so I think that would be much more exciting to me, would be finding evidence for organics in the rocks that Curiosity analyzes. Curiosity is not anywhere near the kinds of rocks where it is expected to find that kind of stuff. We're going to have to wait till it drives to the mountain in order to get to that kind of stuff.
Yeah, and we had talked about this in the past, right? That really the goal of Curiosity is to not only find evidence of past water on Mars, because we've seen that with Spirit and Opportunity, it's to find that those environments existed for fairly long periods of time, and that they were perhaps in conjunction with some kind of energy source, and perhaps in conjunction with some kind of, organic molecules, and that there was like this soup was there all at the same time. And I mean, if that turned up, that would be groundbreaking history books.
That certainly would. I read a couple of things over the last couple of weeks that got me newly excited about Curiosity's mission. One thing I read was Roving Mars, which is Steve Squire's book about the Mars exploration rover missions. And in there, there's a section when he talks about when Opportunity drove down into this crater that had these fine lineations. It was a fairly, like a good 2 meter, 3 meter rock section, and was able to analyze it going all the way down and see how the depositional environment had changed over the course of how many years it was that those rocks had been laid down. Curiosity is going to be able to do that with this instrument that can extremely delicately detect the finest variations in composition. We'll be able to use that to figure out the environment that existed when these rocks formed. With, with a drill, they have this pinpoint precision. They can stick that drill onto a rock and just get the tiniest amount of powder, get that tiny sample into the rover. It's such higher resolution than anything has ever been to the surface of Mars before, and they're going to be able to walk up just meters, hundreds of meters of geologic section and actually tell a lengthy story about the history of this particular spot on Mars. I'm really incredibly excited about that part of the mission and what this instrument's going to be able to do.
But then to kind of take that concept, that theory that I just mentioned, the fact that it's sampling some of the dust out of a sand dune, as you said, which is like this bleaching process, it's very unlikely that they're going to find the kinds of stuff that they're really hoping for, as you said, until, I mean, they haven't really even gotten to the big part of the science yet. Until they get to the wall of the mountain and start to take samples of places that have not been disturbed for long periods of time, places that really have been laid down by sediments over long periods of time, that's when they're going to really be able to get that science done. So so let's go back to the methane idea as well, because I think, you mentioned that Sam can scoop up samples of material. It can process it and detect that, but it can also taste the air, right? And we had that original methane discovery that was a mistake from the Florida methane air, which maybe says something about Florida. But then they were able to do another determination and they didn't find anything. But the thing is that telescopes on Earth have seen methane. There's been a hint of methane from some of the spacecraft orbiting Mars. So, and I think if there was methane discovered on Mars, that would be really, really important, because we do, in theory, you do require some source of methane that can be producing it faster than the atmosphere and the solar radiation is tearing it back apart again. So, is that a possibility to find,
No, I don't think so, because what Grotzinger was talking about was definitely from the solid sample analysis that had gotten in there. One thing that we haven't mentioned about Sam's capabilities yet is this tunable laser spectrometer, which is different from the GCMS. The tunable laser spectrometer has the ability to basically tell how the proportions of different isotopes of very light elements that it brings in, things like carbon and hydrogen and stuff like that. And so one of the things that they had hoped to be able to do was, if they detected methane, they would be able to figure out its isotopic ratio, which might also tell you something about whether it was produced, what the mechanism was that might have produced it. Unfortunately, they did not detect enough methane, or their upper limit on methane is so low that they couldn't, of course, they can't give you isotopes on a sample of nothing, but even if they did find methane at the parts per billion level, it's not clear that they would be able to get those isotopic numbers that they were hoping to get. There just doesn't seem to be enough of it in the atmosphere. However, one thing that they can do is they have, inside the instrument, they have these scrubbers. They're basically like the scrubbers that are used in the space station to remove carbon dioxide. And of course, Mars's atmosphere is like 95% carbon dioxide. So if you remove carbon dioxide, you concentrate all the stuff that's not carbon dioxide. And so Pan was explaining to me last week that they'll take in a sample of air, they'll use the scrubbers to scrub out as much of the carbon dioxide as they can. They'll take in another sample and repeat until they have really concentrated the stuff that's not carbon dioxide in the atmosphere. And so when they've had a chance to do that, then they might be able to possibly detect methane or not, which would also be an interesting result. So that's another example of something that we have to look forward to that's not going to happen for a while.
So we're back to square one.
Of course we are. There's no news, so let's not even talk about it. Let's talk about what Curiosity is actually there to do. And they have actually, there's one more thing that Curiosity has to do before the science mission really can start, and that's to get the drill going. So they've gotten solid samples through their little scoop. They can scoop up soil, but they haven't used the drill yet. And I just want to show you some pictures of the drill because it's really cool looking. So here, to begin with, is a photo of the turret at the end of the robotic arm. This thing is huge. It weighs, I should know what it weighs. It's like 40 kilos. It's quite heavy. And almost all of that mass is in this thing in the center, which is the drill. it's a rotary percussion drill, the kind that you have to use in order to drill into concrete. So it's not actually like getting a core sample. It's designed to bang, 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 bang its way into the rock and pulverize it, creating the powder that they need to put inside these other instruments. Here's no, wait, where is it? Here we go. Here's a super close-up view of what the business end of the drill looks like. You can see up here there are these prongs that are spiky at the end, and what the rover will do is it'll place the drill onto an interesting rock and bring those forward and actually load them down to hold the drill in position against the rock as it bangs into it. And so we're looking forward to doing that. It's going to be happening, hopefully, I think next week, because they look like they've pulled up to a place where they've got some flat bedrock. And I think they're probably nearly ready to get started with the drill. They've been doing checkouts on the instrument so far. Everything looks good. And hopefully we'll see them banging into some rock pretty soon.
But bedrock, isn't a great source of organic molecules.
Well, remember, when I say bedrock, bedrock and rock in general, there are these terms that mean different things to scientists than they mean to everybody else. Bedrock is the goal for geologists. Bedrock is rock that has not been broken up and moved since it first formed. And so you want bedrock because bedrock provides context. It's in the same place that it's always been since it formed. It's so much better than just a random piece of rock sitting on the surface. It's just the same as with archaeology, where, somebody gives you a pot, you're like, where'd this pot come from? They're like, I don't know. And you have to say, I can't tell you anything about the culture that made this pot. But if you see the pot in the context with the food and the seeds and the other paraphernalia from that civilization, you can tell a lot more about the civilization. Same is true in geology. You need rocks to be in place in order to be able to tell anything about the history. So the bedrock that they're looking at right now is something that they've been talking about since before they landed. It's known as the High Thermal Inertia Unit, otherwise known as a high TI unit. And that's just geologists speak for it seems to be a very hard rock. And it's it's kind of unusual in its location. It seems to be unusually warm at night, unusually cool during the day. That's what thermal inertia tells you, is that it tends to hang on to the heat that it accumulated during the day overnight, and vice versa. And that means that it's a pretty well indurated rock. It's good solid rock. It's really good material for them to check out at first, and it seems to have formed from water coming down from the side of the crater and spilling out into the crater and depositing sediment. That's what the geologic context is, and so when they investigate that rock for the first time, they're going to be very excited to find out what it's composed of.
Right, okay. How long until they actually reach the mountain itself?
Well, it depends on how long it takes them. This mission's going to operate a little differently from Spirit and Opportunity. I get the sense that they're going to drive pretty great distances between science stops. The Spirit and Opportunity stopped a lot more frequently along the way, but then Opportunity got into this role where it needed to drive several kilometers across Meridiani Planum in order to get to its next target. And I think that we're going to see Curiosity being more of that style than of the kind of earlier in the Spirit and Opportunity mission style. So they're going to do their stuff at Glenelg, and then I'm hoping to see them really hit the road. It's going to take them a long time to drive the distance in order to get there.
But one thing I've really noticed is that although I think that was the original plan, I think the sensitivity of the instruments on Curiosity is sort of providing such a boon of science at almost anything they look at that it's really hard to kind of keep the big science mission in context, because you've just got such a sensitive suite of instruments. There's a sort of a similar analogy back when sort of people were starting to discover some of the original big Kuiper Belt objects. They were doing these new telescope surveys. They were doing these really comprehensive searches for these objects, and they, because they had access to new instruments, they were turning up tons. That's where Maki Maki and all those other objects came from. But there hasn't been a lot of announcements since then. Right, because and so I think with Curiosity you've got an amazingly powerful suite of instruments that you've dropped on the surface of Mars, and they almost can't stop just everywhere they look. Like, oh look, we've discovered water. Oh look, we've discovered something earth shaking.
You have to realize though that So far, none of the targets that Curiosity has investigated has been selected because the scientists thought they were cool. They have all been selected because the engineers thought they would be good things to test the instruments with first.
And yet, they've been making enormous scientific discoveries from all of these things.
But no, they actually haven't really been making enormous scientific discoveries. They've been making measurements, and most of those measurements have actually confirmed previous guesses about what things might be. It's been extremely exciting to scientists to see these measurements come in, and of course scientists love to find out that they were right, but they have not actually picked out any targets that are designed to answer questions that the scientists had. The one question that we've answered so far is that the instruments seem to work pretty well. And so they've been working extremely slowly. We were warned from the beginning that this was going to be a very slow process to commission the instruments and get them working for the first time. Again, we have one more of those activities to get through. We're still not done commissioning the instruments. The last thing that needs to be done is to commission the drill, use it for the first time. And only then will the rover really be given over to the scientists so that the scientists can actually pick targets that they want to go to and investigate.
All right.
Is it about time to throw it open to questions, I think?
So there's a few questions that have come in. So just to remind you, if you want, you can go ahead, ask any questions that you want, and we will be glad to jump on them and answer them. So first, this is just a comment from YouTube. Emily knows, and that's why she's so unkeen to speculate and keeps focusing on the mechanics of the instruments. So you have been signed to some kind of non-disclosure agreement. You're under embargo.
I actually had somebody send me an email this week that said that they would give a $1,000 donation to the Planetary Society if I was the first one to scoop the information. And I'm sorry to disappoint you, but I actually know nothing. And I'm actually extremely careful not to ask people. I actually don't want to have special inside knowledge. Because it means that there's a risk that I will be the one to spill the beans, and I have done that on a couple of occasions, and it's a very uncomfortable situation to be in. Yeah. I don't want to be in that situation, so I have not asked anybody, nor will I ask. I'm going to wait until the press briefing to find out along with everybody else.
And actually, we have a policy at Universe Today, which is that we don't listen to anyone who tells us that news is embargoed. So if a person tells us that something's embargoed, we say, please don't tell us anymore, wait until you've publicly announced it, and then we'll report on it. So we actually have a no embargo policy with us. So even if I did have the secret knowledge, I would tell the person to wait to actually tell me.
And I will say that, you know, we don't do this just because we're trying to look like we're goody two shoes. We do it because you and I, as people who have a lot of specialist knowledge about this situation, we actually have a really big advantage because we already bring the background knowledge about how these missions work, how the instruments work to bear. So when we do get the news, we don't have to spend nearly as much time doing research in order to get the story right. And so we're at a major advantage, actually, when those stories do come out. We can hit the ground running because we know all the context already.
Yeah, I can't think of the number of times, you know, a lot of those sentences just tumble off the fingers knowing, you know, all of the background and history, you know. Yeah, you've said it enough times. So this is a good question. It comes from Josh Andrews. Does NASA have a process of internal peer review? So how does NASA's process of reviewing this kind of thing, especially if it's really sensitive or controversial, compared to, say, typical geologist peer review?
Well, the first place that the peer review happens is actually inside the mission itself. So Curiosity has an absolutely enormous science team. And that science team, it's got a kind of an organization that's sort of a traditional organization where you have each scientific instrument has a principal investigator, and then there are investigators under them. But they're also using some of the lessons that Steve Squires initiated with the Mars Exploration Rover mission, which is that there are teams on the mission that are not instrument dependent. There are teams that are discipline dependent. So you have a geology team, you have a hydrology team, you have an atmospheres and weather and climate team, and so on. And I don't know if a lot of you have probably not been in a room with a lot of scientists at once, but there tends not to be a lot of agreement in these rooms when exciting data first comes down. And so they usually don't go out to start writing up a press release until there's pretty good agreement within the team that they're ready to go forward with this kind of information. There have been a couple of occasions where I've seen NASA do press releases where there are two scientists on the same mission team quoted contradicting each other because they're both, you know, there's exciting new data, And there's disagreement about what it means, and that too is the nature of science. But most of the time, they do try to make sure that there is at least reasonable amount of consensus within the team before they actually go forward with news. And when it comes to something really sensational, there are more levels of review, but on just about any press release, in fact, any press release, as far as I know, any NASA center has to send it to headquarters for review before it can be released, because it's going out with NASA's name on it. And so there is a very thorough process by which these kinds of things get read by important people. And if they are particularly sensational, then they are particularly careful to have a wide variety of people read it and say, no, you can't say that, you have to be careful about this. And every press release that you read has been carefully hammered and polished over a obscene number of iterations before they're finally ready to push it out the door.
And I know that's what I was talking about,
Yeah. I've actually participated in this process because we were on the Mars Exploration Rover mission on an education public outreach project, and it takes a long time to get through this process. They're very careful.
Yeah, and that's been my experience. Someone said that someone mentioned in the comments that NASA will hype stuff, but I find in general they're trying to do the opposite of hyping stuff. They're trying to control the outflow of information as best they can.
The place where you always see hype is headlines, and that's the nature of journalism. You have to write headlines that'll get people's attention, and so every headline that you read is going to say that something is the extremist something or other. It's the largest this, it's the first that, it's the farthest this. Yeah, exactly. And you get tired of reading these things, and it turns out they're having to slice and dice things finer and finer. Well, it's the most distant sub-millisecond quasar that's ever been found. I don't know, pulsar I meant. I'm clearly not an astronomer.
Yeah.
But my point is that it's the headlines definitely are written to try to grab your attention. So those do tend to be hyped, but hopefully most of you out there are smart enough not to judge news based on the headline, but actually to read beyond that and read the story to understand what is actually being said.
Of course, all of the people watching this are smart enough to do that. So this comes from TQFT Simpson. How deep have the samples been taken from? So...
The samples were not taken from very deep in the ground. So the scoop, it's kind of hard to get context on how big the scoop is, but it certainly can't get any deeper in the ground than the length of your finger. And probably the soil came from even closer to the surface than that. Now, what they can do is they can do something that, again, they've done on the Mars exploration rovers a lot, which is to roll up to something and do what they call a scuff, or actually dig a trench with the wheel, where they hold 5 of the wheels. They put the parking brake on 5 of the wheels. They turn the 6th one sideways and they roll it, and it kind of digs this trench in the ground. And with that, you can actually get much deeper into the soil. The wheels are 50 centimeters in diameter. You can easily get down to 10, 20 centimeters deep, as long as the soil is soft enough for the rover wheel to trench. And so I'm sure they will be doing that to get samples from deeper in the ground at some point in the mission. But these samples were from very close to the surface.
Oh, water. Do you think this could somehow, saline water near the surface? That would be interesting.
That is a question that NASA has considered very, 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 very carefully, because if Curiosity were to encounter that kind of material, then they would have had to sterilize it to a much higher level before they sent it to the surface of Mars. So one of the advantages to being in an equatorial location is that you don't have to do such a careful planetary protection, because the environment, basically, it's extremely unfriendly to liquid water. As far as we know, there's no water in the subsurface down to a fairly deep level, and so odds are virtually nil that Curiosity will encounter such material. You have to get much closer to the pole for that.
These were like some of the planet-wide observations made by the climate orbiter, right? They were able to sort of see the amount of water close to the surface and map it all out, and they're nowhere near some of that. But still,
that's right.
If they found, they dug down a little bit and there was oozing, salty water bubbling up, in a liquid state.
It wouldn't be consistent with physics, so it would be really surprising to a lot of people.
Some kind of methane hydrate under the ground. Just again,
yeah.
Speculating.
Now, what you can find is that Mars's climate does vary the same as Earth's does. It actually varies more extremely than Earth's does because its axial tilt varies over a much wider range than Earth's does, and so there are times in I think it's on a 200,000 year time scale, maybe 100,000 year, I forget exactly, where its axis is nearly horizontal. It looks like Uranus. And so under those kinds of conditions, you actually can have stable brines in some places near the surface for certain short periods of the Martian year. We're not in that kind of environment right now. And so that's definitely not happening at the Curiosity landing site. And so there's absolutely no expectation that Curiosity will ever see any kind of liquid or solid water on the ground. Now it'll see clouds a lot. There's water ice clouds that'll pass by, but nothing in the ground.
So Ron Hicks has just posted onto YouTube what I think is an interesting idea. And he was talking a bit about how they've been trying to quantify the composition of the soil that accumulates in the dunes, and wanting to know about how the dust that circulates planet-wide. So what do you think about that? What do you think about maybe the source of the dust in the dunes being something that's very interesting? Be it maybe a source that's very far away, or maybe of a composition that they weren't expecting to find in the crater itself. That would be pretty interesting. I think a lot of people would be very disappointed, but I know a lot of geologists would be quite interested to see that maybe dust was accumulating or was being transported at a very far distance.
It's one of those things where, like, the Kamen results were very exciting to me because one of the first things that they talked about was feldspar. And now you have to have taken geology, probably a couple of geology classes, to be as excited as geologists were that there was feldspar there. That's a fairly basic thing, but scientists would be very excited about it. And even if you could explain, you can explain to the public why you're excited, but the public will never be as excited as you will be about that particular discovery. So there's very likely to be some kind of mineral in this soil that is very exciting to mineralogists, that implies something just from its name. They know that it means something about how this mineral was made, what it was made from, and so forth. But it's not going to mean anything to anybody who is not a geochemist. And so they'll have to sit there and explain that. And they might even have to take you through some geochemistry classes, as they've done already on this mission before, to try to tell you why this stuff is so exciting.
I'll give you another example, right? What if you find and I'm not a geologist, but this is your field, but for example, one of the big problems with Mars is that it doesn't have a magnetic field, a planet-wide magnetic field, and so it's very exposed to radiation. But again, could there be, I'm not sure if the SAM can do this, but could there be some kind of element or some kind of rock that could show that maybe Mars did have a planet-wide magnetosphere in the past?
No, SAM's simply not capable of measuring anything like that. And the sand is teeny tiny grains, and it's so electrostatically charged. I doubt that it could hold. One interesting thing about Martian dust is that it is ferromagnetic. So that means if you take a magnet with you, as Curiosity has done, then the dust sticks to it. Because and pretty much all of Mars's dust is magnetic in this way. So it's not itself magnetic, but it sticks to a magnet.
Right. So anyway, these are the kinds of out of left field ideas that I'm proposing. One
thing we haven't mentioned yet is carbonates. People have long been expecting to find carbonates on Mars because if you have a carbon dioxide rich atmosphere and you have liquid water, you kind of have to make a carbonate mineral. It's just sort of what happens chemically. And carbonates have been extremely difficult to find from orbit. In the last few years, there have been some patches discovered here and there, but it's really been quite a surprise to theorists that carbonates have been so hard to find. So that, I think, if they found a carbonate mineral, would be very exciting to geologists.
What would a carbonate what would that indicate?
Well, it would indicate that you had an environment that could make carbonate. And in general, those environments are liquid water under a carbon dioxide atmosphere. So it's something that's been expected for a long time and not found. And so it would make scientists feel a lot better about themselves if they could find a lot more carbonate on Mars. And so that would be something to be excited about. But I have no idea. It seems to me that Mars dust has been investigated by the other rovers and other missions. So I don't know. Frankly, all of the possibilities that come to mind sound either not very exciting or not very plausible. So this is why I hate speculating.
We're having fun. Nobody's watching. We're just having fun, just speculating. If I had beer, we would just be drinking beer and speculating. You got water, so we're close enough.
Cheers.
So Jason Weitzel asks, what about microbial fossils? Considering how water worn the bottom of the Jake Rock was, he was hoping that MSL would look underneath it. So microbial fossils.
Curiosity does have a really absolutely wonderful hand lens imager that will take beautiful, beautiful images of rocks. So if there were macrofossils, Molly, which is the name of this, it's a Mars
Mars hand.
It's a hand lens imager, but I forgot what the A is. So Mars hand lens, I think it's just MA. But anyway, so it's a hand lens imager. So if there were macrofossils, if there were, say, seashells or little centipedes
dinosaur
or
bones.
things, dinosaur bones, they would be able to find them. But
not
microfossils,
microbial stuff.
No, it's just it doesn't have the resolution. And one of the things that Grotzinger reminds me pretty much every time I talk to him, his particular expertise is in looking for evidence of Earth life in Earth's very most ancient rocks. And he tells me that this stuff is incredibly hard to find. It is ridiculously hard to find. First of all, it's hard to find rocks of the right age. And it's actually easier to do that on Mars than it is on Earth, which is one reason that you might go to Mars to study the origin of life if you could find any example that any evidence that life might once have existed there. But then even if you find rocks that are old enough, it is so hard to find evidence for ancient microbial life. He says if you find just one new locale, that's a PhD right there. Write it up, you got your PhD done. And so the notion that you might find that stuff, exactly.
Yeah.
The notion that you might find that kind of stuff on Mars it's exceedingly unlikely. Now, you have a guy who is trained and capable of finding this stuff. So you can bet that if there were the kind of evidence that he could see that would point to microbial life having been there on Mars, this is the guy who you would want to ask, does this evidence point to that conclusion? And so you've got the right scientist for the job of trying to answer that question. And they are saying that even if Mars was once teeming with life at this time, the likelihood of us finding fossil evidence for that is actually very low. But we would be able to find the kinds of... they're basically only trying to look for whether there were environments that could have supported that.
Right, because I know there's those rock formations in Australia that they've dated to 3 billion years ago, and they
3.8, some of the oldest, yeah.
Okay, yeah, and they have a very sort of specific look to them. They look like kind of mounds of rock, but they're a special kind of. And I'm sure if the rover was passing through a field of these, they would go and investigate them a little more closely.
Yeah, stromatolites. You're talking about stromatolites. If Curiosity sees a field of stromatolites they'll be very excited.
Very excited. It would be earth-shaking, as it were.
It would be earth-shaking. But one of the things that's impressed me about the Curiosity science team, there is overlap with the Mars Exploration Rover science team, but there's a lot of new faces, and almost uniformly those new faces are Earth field geologists. They are people with a lot of experience in walking around rocky environments, picking up rocks and trying to figure out what they can tell you. So these are guys who have really thought hard about the problem of how you tell the history of a place from its rocks. So I trust them. I trust what they tell me.
So this question, a little off topic, comes from Mutt Liang on YouTube. I'd like to understand better what they mean about surface radiation levels being suitable for, I guess, for a manned mission.
Oh, right. So they have an instrument called RAD, which also stands for something. It was provided by Russia, and it was basically it's basically an upward-looking radiation detector it's kind of acting like a dosimeter for Curiosity. And what they found with that so far, they actually reported results from that last week, is that the radiation levels that they're detecting are not the kind of radiation levels that would kill you right away. So it would actually be safe for a human to operate on the surface of Mars in a kind of ordinary spacesuit for a while. But as with everything with radiation, it's all about cumulative dose. And so the question, could you live there all your life safely? No. The question is, can you live there for long enough for it to be safe for a human to operate in a normal kind of expected mission duration on the surface of Mars? And I think that the news that from last week was, well, yes, but we haven't detected any kind of really major solar event yet. And that's really where you get the bad, the radiation doses is from major solar events. So I think that team is looking forward to the next major, coronal mass ejection that the sun throws out at Mars. And they're going to want to see then what their instrument detects and what that would do to a human astronaut.
Well, we're nearing the solar maximum, so now is the time that those kinds of flares are going to get thrown out. But yeah, I mean, this is the great fear, or the big problem with Mars, that has no magnetosphere, and so no real natural protection to both the sort of the cosmic rays and also the coronal mass ejections coming out of the sun. And so you can bring your spacesuit, you can the air is okay if you've got a spacesuit, you can handle the pressure, you can handle all those things, but the constant radiation beating down, unless you come up with some kind of structure and you live under it all the time, you're going to be getting this cumulative dose of radiation, so that will suck. So Tree Lobsters asks, can Sam detect something like, say, chlorophyll?
Ooh, I doubt it. But I don't know. Somebody tell me the atomic mass of chlorophyll.
But that's the point, right? Is that you're gonna take? Is that a problem? That it's just too big?
Actually, I shouldn't have answered so quickly. So what? Remember how Sam works to detect the solid stuff is that you put the material inside an oven and you heat it. You heat it very, very slowly. And so the first things that come off in the oven are the most volatile of gases. And those would probably be gases from the atmosphere that are adsorbed onto the surface, the little molecules that are sticking to the grains that you've got in there. Once you've driven all of that off, that's water and carbon dioxide and other stuff, then you're going to begin to cook the actual material that it's made of. And this requires a lot of power. So I was figuring out Curiosity's activities over the time that it was at Rocknest. And any time that Sam is operating its oven, they can do nothing else that day. There are no images taken. There's absolutely nothing, because it takes all the power that the rover has to operate this oven. And what it does is it drives off materials. It breaks down the materials. And so you have to know what the material that you're interested in, what it turns into when you heat it. And so it's not a direct detection for some of these bigger, more solid things. You actually have to figure out what gases they send off. And for that reason, they have a complete copy of Sam sitting in a clean room inside their own laboratory. And they've got a whole science team that is devoted to figuring out things that might be on Mars, sticking them in Sam and seeing what comes off. Right. They've developed a library of materials before they landed. And now that they've landed, they're coming up with lists of more things that they need to try. And so before they are ready to say anything about anything unusual that they find, they're going to need to run laboratory experiments on the breadboard that they've got sitting in their own laboratory on Earth to say, yes, we tried it on Earth and we were able to duplicate our findings using this mixture of these kinds of materials on Earth. So the process of actually getting scientific results out of Sam is going to be kind of slow. It's fast for atmospheric results because those are so much easier. You're actually measuring what's already there. It's much harder for the solid stuff because you're measuring stuff that comes off of things as you cook them.
Right, but if Sam, say, bakes an apple pie, if the smell smells like an apple pie, then maybe that'll be chlorophyll, right?
What?
Well, because there's chlorophyll in apples, right? So we've got 5 more minutes, so we'll take a couple more questions and then we'll let you get on with everything. So I guess this comes back to the radiation problem. How difficult would it be to generate a sufficient EM field to protect future astronauts?
I'm afraid you're asking the wrong person. I don't have the qualifications. I have no idea how to answer that question. I do know that electrostatics are a real problem. This rover actually has, if I had time, I could go find you pictures. There are little lightning rods that are designed to help discharge static electricity. The Martian dust devils that take all of this dust and whip it up and rub it against each other. You know how you rub a balloon and it sticks to your head? The same thing is happening in Martian dust devils. They can build up a huge electrostatic charge because Mars is so dry. There's nothing to conduct this charge away. And so you actually have serious problems with static electricity on Mars. It's something that they're going to have to plan for and deal with in future human exploration.
Yeah, and so humans, although it's not the same kind of nasty dust that they find on the moon. Like the moon dust is this really sharp, gets in your lungs, gives you cancer kind of dust.
Yeah.
While the stuff on Mars has been worn down, and so, but it's going to get everywhere.
It gets everywhere. I mean, you just look at any surface of the rover. It doesn't matter what direction it's pointed. It's already coated in red dust that was kicked up during the landing, and it's just going to get worse. And so you're going to have to deal with the same stuff. It will get inside everything. It will get through every joint of everything and just make it, you will taste dust. Everything will just taste dusty. Your eyes will be dusty. Frankly, I don't want to do it. I'd much rather be in orbit, teleoperate some awesome robots, that can run across the surface many kilometers than just take me, who could maybe walk couple hundred meters very uncomfortably in a spacesuit and not actually be able to do much of anything because the dust was making me blind. That's my editorial on human exploration of Mars.
Good. Well, I think I've got all the questions. Some people were mentioning we're missing the ones on Google Plus, but I thought we were grabbing them.
Did you check the event?
I checked the event.
Okay.
But I will check it again just to make sure.
While you're checking, there is something that I'm supposed to be
advertising.
Oh yeah,
no, there are a bunch of questions here on. Okay, I'll grab a couple of these here on the event. Man, this needs to get fixed. Someone mentioned that I'm going off the deep end. I'm often going off the deep end.
It's what you're here for, Fraser, and I'm here to reel you back in.
Yeah, I know. That's the same role I play with Pamela. She's like, come on, let's just imagine. What if? Okay, so here's some questions, some theories, some theories. So, what about some kind of underground structure? Would not some temple or some Prothean artifact.
It's not something you would detect with SAM.
But right, you wouldn't detect it with SAM. You might, but
next question.
But it has no. Hold on, wait. Yeah. It has no ground penetrating radar. It has no way.
It does have one instrument that does look underneath the rover, but that instrument is solely capable of detecting the quantity of hydrogen in the soil immediately beneath the rover. So it's not going to be able to say find underground caverns or something.
Okay, all right. Because one of the big discoveries on Mars is these amazing underground caverns, these skylights that have been found. And they are absolutely the kind of place that you would want to investigate, and you'd probably want to map them from above somehow. I don't know. There aren't any missions in the works to investigate any of these lava tubes, are there?
No, and they're actually, they're cool because they would be great places to live for future humans visiting the surface of Mars, because you'll wind up with a lot of rock over your head to shield you from all of that nasty radiation. So they're great sites to investigate if that's what you care about. As far as the geology goes, it's not any more exciting than any other kind of igneous geology, which is to say they'd be really cool to investigate, but not any more so than any of the other kinds of rocks that Curiosity was sent to investigate. They have these lava tubes and skylights on the moon too. They're pretty cool.
I know. There's one more here that was good. So this comes from David Roberts. What percentage of Martian rock is sedimentary? 0? They have...
Oh no, a lot more. Yeah, lots more than 0. So almost all of the rock that Opportunity has ever driven on is sedimentary, for instance. And so there's different ways of making sedimentary rock. You can have most of what Opportunity has been driving on is either evaporite or it's a Aeolian sandstone. So it's sand, windblown sands that have been cemented and turned into rock. And so sedimentary rock doesn't only form in the presence of, say, a long-lived deep-water ocean. You also get a lot of sedimentary rock on Mars because we know that there was water in those outflow channels. All of the stuff that deposited when it turns to rock, that stuff is sedimentary rock as well.
Ilya B asks, is there a chance to find a meteoroid in the Martian soil?
Oh yeah,
but they found them, right?
Yeah, they found, and Opportunity in particular has a relatively easy time finding meteorites. It's kind of like how you go to Antarctica to find meteorites because you can spot them on the ice. Opportunity was traveling in this vast sand desert, And so it was very easy for Opportunity to spot meteorites. So Opportunity has spotted, I don't know, I think like 10 pretty large meteorites. They speculate that a bunch of them may have come from the same fall, but it's kind of hard to tell with Opportunity's instrument suite whether that's true or not. There's really no way of verifying that. For Curiosity, it'll be a little bit harder because you've got a lot of rock in this landscape. That's why they're there. And so it will be a little harder to spot them from a distance, but I have no doubt that they'll find a meteorite at some point during the mission.
Yeah. John, actually, there's a great experiment you can do. I don't know if you've done this. If you haven't cleaned out your gutters for a while, you can scoop out your gutters. You can take all the dirt and put it into like water with mud, and then you can put a magnet into it, and you can pull out magnetic particles, which are range from space.
Well, that's cool. I haven't tried that before.
You know you can do that? Yeah.
No, I didn't know anything about that.
I actually have to muck up my gutters. Maybe I will do a YouTube video on this. So John Reher asks, one bit of speculation found by Curiosity was that they found perchlorates. What do you think about, what were the implications if they found perchlorates on Mars?
Well, Phoenix has already found them, so it wouldn't be a big surprise. But, you know, it does bring up, they could find something that has bearing on the Viking life detection experiments, but I wouldn't really know what that would be. It's kind of getting outside of my area of expertise. But I could see that being kind of exciting to some Mars scientists. I don't know exactly what that would be, though.
Okay, so Tara Mulder says, it would be cool if Curiosity found evidence of some element that's actually quite rare on Earth. Could it be desirable to have more Mars missions and return material back to Earth? So that would be interesting, right?
Well, there are materials...
platinum in the...
You're not going to find vast platinum deposits on the surface of Mars, and even if you did, it would be much easier to get them from asteroids. So Mars does have minerals that are very rare on Earth because it has different geologic processes or a different balance of geologic processes. But I don't think that... I think that Earth's geology is much better at concentrating economically interesting minerals than Mars's is, and Mars and Earth have the same problem that almost all of the economically interesting stuff is in the core, because it went there with a lot of, if it likes iron and nickel, it followed the iron and nickel. There are other things like the radioactive elements that don't like hanging out with iron and nickel, and they tended to stay in the mantle. But it takes Earth's kind of recycling of rocky material in order to concentrate the uranium and other stuff like that into the sort of deposits where we get it from now. So Mars is not as likely to have that kind of stuff. And if you're talking about economic geology, much, much, much better to mine an asteroid.
So Chris L. says... And this was in my line of thinking as well, right? Which was that because the comet is earth-shaking, right? So could there
I
be
think
evidence
you're reading
of some...
way too much into
I understand.
it.
Well, no, this is just not me, but I also think the same thing, which is evidence of some current geological activity, tectonics. Which one of the big questions about Mars is it still geologically active? And so.
I don't think you would find that in a sand sample from a sand dune. Yeah. That's the kind of thing that you find out from orbit. And people have been trying to say that there's plate tectonics on Mars for a while, and most geologists, you look at the evidence and it's just not there. There has been tectonic activity. There has not been plate tectonic activity. There's been plenty of tectonics. Valles Marineris, for instance, is like 3 or 4 gigantic cracks in the crust of Mars that have then been hollowed out a little bit more by water. But yeah, I don't think that anything that Sam could find in a sand dune would tell you anything about tectonics on Mars.
So that's it. That would be the pun-worthy answer to the mystery. So there you go. So we've been speculating. We haven't, we held your feet to the fire a little bit, Emily, but at the same time, you haven't committed to anything.
Nope.
Nothing embarrassing is going to happen, and I think that's great. So hopefully when people get a chance to hear what the actual finding is, they will have a little more information about the instrument and the kinds of possible discoveries, and they'll be able to put it into context with all of this stuff and either freak out about NASA overhyping something, or be suitably awed and amazed. The thing is,
first of all, NASA was not overhyping anything. There was a scientist who was really excited about getting some new data. as any scientist on a brand new mission is going to be. And it may be that there is a possible result that does turn out to be extremely exciting scientifically, but I'm kind of frustrated by the people who are upset with Grotzinger for being excited about his data, because that's what scientists do. We're in this because...
That would be me in a heartbeat. I could not keep my mouth shut.
And you know, I mean, most of the time you get really excited about something and they're like, oh, wait, I forgot to carry the 2.
Yeah.
Like, there it goes, it's gone.
There it goes, it's all gone, yeah.
Yeah. And so, and that's why they're not telling us what it is, because there's probably 9 different things that could explain whatever this thing is, and maybe all 9 of them are wrong. We don't know yet. And so there's really no point in asking the scientist to tell us what those 9 things are. On a mission that wasn't quite so much in the public eye as this one, it would make more sense. It would be more fun just to sit down with the scientists and say, hey, what could this mean? But this one, because the results are so new, and frankly, because anything that they could say now other than we've confirmed past measurements is likely to be wrong, I really don't want them to say anything, because it's just going to be stuff that I'm going to have to take back in the future. And so it's just it's a waste of everybody's time. Yeah. And furthermore, let the scientists be excited about their data. It's what we do. It's why we're in this.
All right. Well, this was really fun. Thanks, Emily.
Cool. Yeah, it's always fun. And I did find the thing that I was supposed to advertise. Ray Sanders asked me to say that we've just opened up registration for another CosmoQuest education course. He's teaching galaxies and galaxy clusters starting November 26th. So go to cosmoquest.org to learn all about that.
Yes.
And are there any hangouts that you want to advertise?
Yeah, so we actually are catching up some missing episodes of Astronomy Cast. We did 2 episodes today. We did the cosmological constant and we did the Hubble constant. Tomorrow we're going to do, so that was very high concept stuff. Tomorrow we're going to do explosions in space. Woo. So that'll be tomorrow. And then of course on Sunday we're going to do the virtual star party, and we're going to open up a bunch of telescopes, point them in the sky, and take requests.
And my next science hangout is going to be 2 weeks from now, but it will no longer be on Wednesdays. I'm moving my time slot to Thursdays at noon Pacific time. So follow me there. I hope that more Europeans will be able to watch what I'm talking about, because right now it's just terrible. It's in the middle of the night for them.
Yeah. We can't please all people all the time.
All right, Fraser, I got to sign off. My kids have finished watching Beauty and the Beast, so I need to go help them out.
All right.
So I'm Emily Lakdawalla for the Planetary Society. This is Fraser Cain of Universe Today. This has been the CosmoQuest Science Hour. I hope you'll check out more hangouts at cosmoquest.org. I hope you'll check out our blogs and other writings at universetoday.com and planetary.org. And thanks for watching, and I hope you tune in 2 weeks.
See you later, Emily.
So, bye-bye.